Okay, so again, up until this point, we have had equations in one variable, so if I give you another one, let me see, what could I say? How about a plus 8 equals 12? I might switch to that, but if we have a plus 8 equals 12, a equals 4. So you know that you can use your inverse operations to solve for one unknown. And 4 is the solution of this equation. And is there another solution to this equation? No, there's just, that's it. So today we're moving to equations in 2 variables. We will see 2 instead of 1. So when I give you this kind of a basic little equation, x plus y equals 6, jot it down. Now the solution is not just one number anymore, is it? So if I tell you right now that x is 3, then what is y?
3.
If I tell you x is 0, what is y?
6.
If I tell you x is 6, what is y?
0.
Do you see? How many solutions are there to this type of equation? Infinite. I could even give you a negative. If x is negative 6, y is? Well, good job. I heard it right away. 12. Negative 6 plus 12 will get us to 6, right? So the solution to a 2-variable equation is a point. It's an ordered pair. If we plug in, as we just said, if we plug in 3 for x, then the y value will be 3. If we plug in 0 for x, then the y value, you said, was 6. If we plug in negative 12 for x, no, I didn't say negative 12, did I? I said negative 6, that's right. If we plug in negative 6, then you said the y value would have to be 12. Do you see, we have right here 3 solutions, and there are infinite others that we could come up with. Okay? These are just 3. So solutions are ordered pairs. And what does an ordered pair look like when we graph it? It looks like a, well, on a graph, can we locate this place? We call it a, not in math, we call it a point, okay? And it does look like a dot, so we call it a point, okay? So the solution of a equation in 2 variables is a point. As a rule, we can just, it's not working today. We can put down, it looks like xy, an ordered pair. Why is this working? Well, let me grab that. There we go. And finally, we could say in words that the solution is an ordered pair. There's order to it. What type of order is x, y in? Stuart? When you think of x, y, that order is just simply alphabetical. That's right, alphabetical order. Okay? So when you're given variables, often when they're put, if you have 2 variables in an equation, they'll be placed in alphabetical order inside of parentheses. X, y are the most commonly used letters for points, right? And so we put them in that order. X comes before y. Okay? And is there any superstar out there who can tell us what we call the x or the first number in an ordered pair? There's a really fancy, kind of almost Latin word for that. It's a hard word. Jake?
Axis?
No, but that's a good guess. That's what we would, where we would plot it, right? On a coordinate plane where there's an axis and all that. Brian? A what? No, it is called the abscissa. Can you say that?
Abscissa.
Abscissa. So the first number, the input number, the value we call it part of the domain. The thing that you put in is usually your first value, the x value or the abscissa. And what pops out is, anybody know this one? Probably not. And so maybe you'll remember this and be a superstar in the future, called ordinate. Can you say that?
Ordinate.
The ordinate. So the abscissa is what we usually refer to as the x value, and the ordinate is the y value. Okay, so let's do the first thing. The first thing is simple, and it's just tell whether the ordered pair is a solution of the given equation. So you're going to have to jot it all down. Tell whether the ordered pair is a solution of the equation. So you're given an equation, x minus 8y equals negative 10. And you're given a point, 2, negative 1. And you're asked, is this point a solution? So Spencer, how will you be able to find the answer here? What are you going to have to do? Very good. What'd you say? I don't think this can hear you, so I'll say it. You said plug in the numbers. That's right. And so be careful to plug them in to the right letter, right? So you want to tell me how we substitute these? Okay, 2 minus 8 times negative 1 equals negative 10. We're testing this, so I like to put a little question mark over the equal sign. When we substitute 2 and negative 1 in for x and y, is this true, this equation? So let's try it. What is negative 8? Let's change this to adding the opposite first. What is negative 8 times negative 1? Positive 8. So we have 2 plus 8. Does that equal negative 10?
No.
No. It actually equals what?
10.
Positive 10. So this is not a solution. And you can abbreviate it that way. NS, not a solution. Okay? So maybe 2, negative 1 is a solution of some other equation, but not this one. Right? It will not be true here. Let's try this. 2x plus 3y equals 29. Is this point 4, 7 a solution? And tell me how we can substitute, Emily. Okay, so 2 times 4 plus 3 times 7. And I'm going to use that question mark again because we're testing it. What is 2 times 4? And what is 3 times 7? And does that equal 29?
Yes.
Yes, it does. So, yes, this is a solution. 4, 7 is a solution. Are there other solutions to this equation? There are a lot of others, but this is one of them. There are infinite others, okay? Okay, and finally, you may be given an equation where you're asked to find solutions for it. And then it's up to your total creativity. You can find any of the infinite solutions available in this equation. But before we find the solution, we can make this a lot easier by isolating the y. So that's the first thing we want to do. Solve for y means isolate it. So this is what we were doing in the last chapter. We were using our inverse operations to get a variable alone. So we'll do it here. We want to get everything away from the y. So does anybody have a suggestion? What's the first thing we could do to move stuff away? Jake.
You add 5x to
So if we add 5x to both sides, what do we have left? As you look, what?
You have 14x on one side.
You do. So, but the problem with this is, what is 5x plus 5x on the left side? 10x. So you grabbed addition because you saw what operation?
Subtraction.
And so you grabbed addition. That's really a common thing to do, right? But we weren't subtracting 5x is the problem. We were actually subtracting y on the left side here. So this is not going to get y alone. But it sometimes is the first thing somebody will think. If you want to move that 5x away, what would you have to do, Jake?
Subtract.
Good. Let's do that. Subtract 5x. Subtract 5x. Now be super careful here, because what's left on the left side? On the left side.
Negative 1.
Negative y. And in some of your tests in this last chapter, you actually thought that y was there and not negative y. Okay, so be careful. Okay, so on the left we have our negative y. Watch out for the right. What do we have left on the right?
4x.
I thought you were going to say that. I heard somebody say 4x. So if you say 4x, Audrey, do I have 9x take away 4x?
No.
That's not what this says. So these are unlike terms.
Yeah.
It's like I have 9 boxes minus 5 iPads. Do I now have 4 iPads?
Nope.
No. I have what, Audrey?
9 minus 5.
That's exactly right. Okay? They are unlike, we cannot combine them. So now the problem is we have a negative in front of the y. And what number is also in front of the y that we can't see? That's right, the invisible number 1. Sometimes it's good to put it there, and it kind of reminds you of what you need to do. So, Colin, what do we need to do to get rid of that negative 1?
We have to divide it.
Divide by negative 1. And so we divide all terms by negative 1.
Oh.
Because when we divide negative 1 by negative 1, we get a positive 1, right? But now, don't forget all terms must be divided by the negative 1. So we end up with negative 9. And don't forget, this is a negative term, right? So what do we have?
Positive 5.
Positive 5x. Good. Okay? Okay, so in the assignment, if you are asked to solve for y, isolate y. And then, now you have an easy equation for coming up with 3 solutions. Okay, you can put whatever numbers you'd like in for your x. It's nice to make a little table for this. Okay, what's the easiest number on the planet to plug in?
1.
I didn't hear it yet. I heard 1 and I heard 2. Do something easier. 0. 0 is my favorite number to plug in. Okay, when you plug 0 in, we have y equals negative 9x plus 5 times, I'm sorry, what am I saying, 9x? Negative 9 plus 5 times 0. And 5 times 0 is 0. So y equals negative 9. When you plug in 0, it wipes out that whole 5, doesn't it? Okay, what's the next easiest number, you think?
1.
You want to plug in 1? Again, you may plug in any x values. Try to choose the easy ones. Negative 1 might be another easy one here, right? Because negative 9 is the first term. Adding 2 negatives is an easy thing to do. Okay? So when we plug in 1, I'm going to do this in a different color. Y equals negative 9 plus 5 times 1. So Ryan, what is 5 times 1?
5.
So what is negative 9 plus 5?
Negative 4.
Very good. So we get negative 4. With each different input, you will have a different output. Yes. Okay? And finally, when we plug in negative 1, did anybody scratch that out already? When we plug in negative 1, we get?
4.
Oh, we better do it together. This is the original equation. And when we plug in negative 1, what is 5 times negative 1? So negative 9 plus negative 5 is negative 14. Okay, so you need to go work it out. Okay? So the answer, you write in the back of the book, it's going to say answers will vary. It depends on what you choose. There are infinite possible answers. They probably will give you a few answers based on 0 and 1 and 2 or something like that. If they give any, it'll be that. Sometimes they'll say use these values for x. They'll say use 0, 1, and 2, and then everyone will agree on the answer. But if they just leave it up to you, you could have something extremely different than the key. Okay?
Everyone's going to be asking you if
Right. Okay, let's try this. Find 3 solutions. And this is from the GP on page 317. So isolate y if you need to. If you don't need to, in number 8 and 9 you don't need to. Just find 3 solutions.
First you have to subtract 3x.
Good job. So subtract 3x. Be super careful about like terms now, right? What do you have left?
Y
Equals.
equals
This is negative now.
4 plus negative.
Or 4, okay, she said 4 plus negative 3x. That's one way to say it, right? Or 4 minus 3x, you could say. Okay, good. And now we're going to find values. If we plug in 0 for x, it wipes out that whole negative 3, and y equals 4. Good. And did anybody have an easy number? What's another easy number, Jake? Okay, negative 3. Negative 3, when we plug that in for x, we have y equals 4 plus negative 3 times negative 3. What is negative 3 times negative 3? 9 plus 4 is 13. So a negative number is nice in this equation because it's being multiplied by negative, right? How about negative 1? Isn't that okay to use as well? If you plug in negative 1 right here, what happens to the negative 3? It becomes 3, and 3 plus 4 is 3 plus 4? 7. Okay? Okay, good. And now you can have fun on your own. There you go.